I've got to find the exact value of the gradient of this curve, therefore I'm going to need dy by dx. Oh, but before I do that, I'm going to put it into this bit into nice form. So that's y equals something to the square root. That's going to be 4x minus 7. And the square root will be to the power of a half. And then plus, or this is the quotient, so I'm going to have to use the quotient rule when I come to differentiate that. So now I can do it. Dy by dx equals, differentiate this, the half comes down to the front. I have the 4x minus 7, and the power decreases from a half, decreased by 1, so that'd be to the minus a half. And then I have to also times that by the derivative of the bracket, so I've got to times that by 4. So it does the first bit, and then I need to differentiate this. And I'm going to have the top bit is u, and the bottom bit is v, so I'll put them in brackets. And so what I want to do now is, I call it the voodoo approach, because differentiate this, it always starts, whether it's product or quotient rule, as voodoo. So it'll be v times by du by dx, and it's a quotient, it's minus u div, and then divide by v squared. If it's a product rule, it'd be voodoo, and it'll be plus u div. So here we go, voodoo, so v, so it's going to be 2x plus 1, voodoo, du by dx, so differentiate this, that'll be times by 4. It's a quotient rule which is difficult, so therefore it's going to subtract, and then u div, so it's 4x, and dv, that'll become, to differentiate the v, that'll become times by 2, and then that's all over v squared, so that's 2x plus 1 all squared. Now I'm going to actually, so before I put in 4 here, I'm going to tidy this up. I've got 4 times a half, so that'll be 2, and then this is to the negative, so it's going to be over, so it'll be 2 over, and that's used the 4 and the half up to get me 2 at the top. It's used up the negative sign because that's the 1 over, and now I need to do 4x minus 7 to the power of a half. That means the square root of 4x minus 7, and then that's going to be plus, that'll be 8x plus 4 minus 8x, that's nice, all over 2x plus 1 squared. And now I just had to put in x is 4. So just a few little words like this, when x equals 4, that's useful, okay, because it tells me exactly what's going on and the examiner what's going on. So dy by dx equals 2 over 16 take away 7, that's to be 9, so that'd be the square root of 9, plus the top bit, obviously 8x take away 8x is no x's, so that'll be 4 over x is 4, 2 fourths 8 plus 1 is 9, so that'll be 9 squared. And this equals 2 over 9, that's 2 over root 9, that's 2 over 3, plus 4 over 81. And it wants the exact value, so I now have to work this bit out. So I have to times top and bottom here by 27 to get 81s. So that'll be 481, and that'll be over 81, and that'll be times it by 27. That'll be 54 over 81, and so that will be 58 over 81. But obviously you've got a calculator, so you could have worked it out much earlier on than that. And that's question 4 done.